Right, so welcome to this stream. I am going to stream a pre-recorded session that I did with a few students earlier today, and hopefully you guys can find it interesting. We are working on a challenge where we are invoking the navigator function, the geolocation function of the navigator, and we are based on the response we're getting from we're hitting an open weather API, and then also another API called OpenCage to get information about the location itself, like the city name or and some other data. So it's one component that does a lot of things, and the challenge that we are giving those participants in this particular workshop is to take that data and do something with it, like display it on in a chart or what have you. So that could be interesting, hopefully. I will be monitoring chat, but this is a pre-recorded session. Let's see if we can get this thing off the ground. Feel free to ask questions in chat if you want, but let's get after it.
Thing before we move on. Observables.
I need to get the sound, the PC sound into the presentation. Sorry, let me just get that up and running. PC sound, PC sound, PC sound. Let's do this, and we get. Sorry about that. Where am I? I'm here. This is the scene, and I want to get the video in here. Right. Exactly. This is me. I'm gonna shut myself down, and now we're gonna start the thing. Right. There we go.
Right. Okay, gentlemen. Let's start with one thing before we move on. There is a way to check permissions of the navigator object, like this: navigator.permissions.query name geolocation, and you can have a callback, then console log this thing, right? So we can try that, and we will actually try this in just a few seconds. But for now, your weekend challenge, let's talk about that. So your weekend challenge will be to visualize, no, sorry, that's the one, here it is. Visualize your data that you are receiving. And this is the implementation of this weather app challenge, written by Lucas and Miran, I guess. No, it was only you. Once again?
No, exactly.
Yeah. And now I just opened this up. I cleared my cache, right? So I opened this up for the first time. And as you can clearly see, we have this pop-up asking me whether I want to allow or block my my access to this thing, right? So before we do anything, I will allow it, of course, but before we move on to that, I want to open this up in an incognito window. So I have a different history. And here in this window, I will actually block this, just so we can take a look what happens when it's being blocked. Is that okay, guys?
Yes. You want to see
it?
Yes.
Yes.
Well, I don't think I implemented that functionality, actually.
We'll see. We'll see.
What?
But that's not, I mean, don't worry about the functionality. The only thing I want to check now is if we can get those navigator permissions, okay? So I'm blocking now, and this will, of course, not work anymore. And if we take a look at the console, you know, we don't, like in the network, we are apparently not making any calls or anything. Let's reload this again. You see, nothing is really happening here because we are trapped in this function, right? That, you know, since you are not allowing this, nothing will move on, basically. You understand the concept?
Yeah.
Right? Yes or not?
Yes. I was sitting here nodding like.
Thank you. And so let's take a look at what this guy is doing. So he's looking at navigator permissions, and then he says query, and inside of this function, he's using a destruct of a name geolocation, and then console logs it. So let's see if we can do that, okay? So we say navigator dot permissions, right? If we just look at that, let's take this step by step. We get an object of permissions, and that is just an empty, doesn't contain any info that is valuable to us. So then we do query, if this even works. That's how we did it, right? Yeah. And then we do this, and we say name geolocation. I don't know if this will fly or not. And then we want to console. This looks weird to me, to be honest. Console log, and then we want to console log geolocate. This is not going to fly. This needs
just want to console log.
No, this is going to be this only works for Blink and Firefox. Okay, that's not going to work for us at all. That's not going to work for us. This needs to be a callback. So res, and then let's just do res, if anything. Yes. Oh, this actually did work, but it was slightly different than I had to modify this. Right. Well, actually, I'm just going to try his way, but I don't know that. I mean, this is not going to console log anything. So this, you know, the way he did it, it's just right. It's not going to fly at all. But this flies now, and we can see permission status and state of this particular, you know, this particular permission is denied, right? In this one. So let's have a look at the one that I opened here, and here I'm going to allow this, right? In my right, so there it is, right? So we can Google Chrome system says, forget about it. Right, so this actually worked, and we can see this graph here, and this is your weekend challenge. We want you to implement some sort of a data visualization module in your weather app. Whether it's this, like a line chart, it could be many other charts, or you can do whatever you want. And Lucas will talk you through how he did it, and it will be up to you how you want to do this. In his implementation, he has a daily temperature, which is historical data. He has a 5-day forecast like this, and then UVI 8-day forecast, whatever that is, Lucas. What is that?
The sun, how sharp the sun is, I guess.
Okay.
So you know when to go out and get a tan, basically.
It's for us people that burn easily.
Yeah. Well, then that might be useful. No, but I like this. You know, he's using different type of data visualization. Some icons here, a bar diagram and a line diagram here, and it's up to you to go through that. Now, let's just return to this question about permissions, because we did allow it to happen here. So I'm going to open up my dev tools here, clear the console, and I'm going to run the same thing as I did in the previous window. I'm going to run it on this one, and it says that the state was granted.
Grant. That's cool.
Do you see that? So this is definitely an interesting thing. I'm going to select this over to you guys in your channel. This could be useful for your implementation one way or another. There we go. Right, but there are other ways to do that. Now, if you look at this example, this is where he is actually querying for this, but he's using watch position instead of get geolocation. But you can probably rewrite this function for get geolocation, you know, and there, you know, on the error that is being raised, because when you deny it, an error is being raised, then you can just check for the error, whether it's permission denied, probably. And there must be another way, get current position. Right, you have a success callback, and then you have error callback. So the first one is what should be run when you grant the thing, the tracking or the geolocation, and the second argument here will be a function that is invoked whenever an error occurs, and then you will get probably the same type of object. So there are different ways to deal with this, but you should be able to figure something out and stub this out in Cypress. Now, if we take a look at, does that make sense, by the way, people?
Yeah.
Yes.
At least you can play around with it.
Yeah,
check.
exactly.
Yeah. All right. So if we take a look at these two charts, the daily temp and the UVI forecast, these two are being built using this library. The library is called React Chart.js 2, right? That version, and you get a lot of examples here. Now, Chart.js is a JavaScript library, and React Chart.js is, of course, a wrapper for React, right? There's probably a Vue Chart.js and all of that stuff, right? And it's pretty powerful. You get a lot of different examples. No, the different charts that you can use. There's a bar chart. You have, I think you have line chart examples here somewhere, and so on, right? But if you want, like, there are examples here, the components, right? So you have a pie chart, mix, like, you know, different options. So you're gonna have to go through this these examples, how you actually deliver them, right? Like, for instance, you have this pie component here, and that you pass in a data prop to, and you create the data here in a specific format. So you have labels being some sort of labels, right? And then you have to add some colors to it, and some values, you know, how to display this, basically, right? So that is one way of doing that. And if you're unsure about this, you know, how to, you know, what is possible to do. So apart from checking the examples, you can also go to the Chart.js documentation, which is the original library that this one relies upon. And you can get a lot of documentation here, but you have to understand that this one is pure JavaScript. So this, you know, you can look at what is possible and how your data sets can look like and so on, but the actual rendering needs to come from the JavaScript, from the React version of this thing. And you can see here different chart types, like donut and pie charts. You know, you can do something like this. You can do something like this if you want. For some reason, scatter charts could be interesting, and you can mix those different types with each other and so on. So this kind of libraries are often very good to know a little bit about, because it requires you to work with data structures in a specific way, because every chart, every line, every diagram accepts different types of data structure or format. So it is a good practice in attention to details, basically, and trying things out. So it is not an easy challenge, let me assure you, because it will take a lot of try and error. And this is also very hard to test, so do not even attempt to test it, because it's these charts are they do render a canvas, and inside of that canvas you have different, way of displaying this, and you cannot test that in Cypress at all in any way. And also, one would also argue that these are visuals, and visuals shouldn't be tested too much. So don't worry about that. So Chart.js 2 and React Chart.js 2 are the two libraries that will come into play. And with those, you can choose what sort of data you want to visualize from the open weather data response that you get. And there's plenty of data there that you can look at. This one call API endpoint is returning massive amount of interesting information to us. So you can go crazy on this one. Any questions so far?
No,
Not yet.
Not yet.
Lucas, how did you change the question mark to a cloud like that?
Oh. Well, I created like a long condition, because there's somewhere in the what's that called, the response, that says what kind of type of weather.
I see. Yeah.
So it has sun and rain and clouds and all that stuff.
I just thought it was cool. Yeah.
Oh yeah. Oh, you mean those?
Appreciate
items.
it.
No. At the top when you started, it said weather and there was a question mark, and then when it took your weather position, it changed to a cloud and clear. Top right.
You see,
okay.
these are also clouds. Then it's kind of the cloud, but the clear has a clear one. If it's a sun, it's a sun.
Right. And
I can show you that in a second.
because Lucas will talk you through his implementation. Actually, that's part of this session. Now, before we move on, I just wanted to go to this extra challenge and preview this one. Now, right. So if we take a look at this guy, and I know that this might be a bit much for you. So I did include this component. This one looks different than a bit different than the one that Lucas is using, but it's based on his implementation. But the biggest change here is actually what happens when we're mounting this component on screen. And I just want to talk you through this, because you see, what I did was I changed the navigator geolocation to an asynchronous function, right? So we wait for this to happen in a different way than the way we did it before, with a then and catch and so on blocks afterwards. So I have this function called get position that returns a promise that is either rejected or resolved, and that will be done by the function. And if we take a look at the component did mount, I turn this into an asynchronous function. And so we on this line, on the first line of the component did mount function, I'm getting the position from the get position function. And then I update state with that data, right? But I also extract the latitude and longitude so that I have it in this function. Could be a const. It doesn't necessarily have to be a let here. And then we are making two consequent calls using Axios, one to location, to the open cage data, and the second one to the open weather map, okay? Using Axios get, as you can see. And then we are updating state again with parts of the response for some reason. I can't really remember why I did that, but that's what we are doing here. But here comes another thing where I create a new constant that I call weather info. And here I create a location, a temperature, and a weather properties, right? But the location is the one that is a bit complex, and it also relates back to what we discussed in this morning's Scrum, because here I'm using a ternary operator, right? We are looking at the location response data, the first results, and we just check, is there a village, or not? And if it's not, well, if it does exist, then we set this location to that particular village. Otherwise, we're setting that to a postal city. The reason why I took village is because Virum is outside of Copenhagen, so it's not a city, right? If I'm not mistaken here, Lucas. We did play around with whether we should city or village or coastal city or what have you. So this is one way of doing this. Like, you just use you choose between two of these results, but this is in no way comprehensive enough. So because there might be a village, there might be a city, might be a postal city, or there might not be anything at all of this, right? So what I would do if I were you, or if I worked on this challenge again, I would probably extract all of this to a separate function, or even a module somewhere else in my application, where I will really go through all the different scenarios that could arise. If there is no postal city, fall back on city, fall back on village, fall back on, whatever, right? But this is a problem with the Open Cage API, because the response is different, as I said, depending on where you are in the world. And that is usually not a very good situation for a developer, because what we really look for when we ask for something from an API, independent of what sort of API it is, it's predictability, right? We want to know that certain attributes will be there. They might be null, or they might be not set to anything, but they will be at least present. You understand? And here we are facing a situation where they are not present. Village is not present in this response if you are querying this from Stockholm, and because then city is present and so on. So this is a bit of a problematic situation, and it is actually addressed in the OpenCage website. So if you go to the API documentation, there is, let's see, best practices. Well, I know that I can't really find it right now, but I know that there is something said about this in these docs. Can't really find it at the moment. Fuzzy matching is interesting also. Yes, Lucas, you were about to say something?
No, I just said fuzzy.
Fuzzy. So fuzzy logic is an interesting concept, but let's talk about this later. But anyway, never forget that there is a lot of docs here that you can work with. So don't forget about the fact that there might be a lot of information needed for you to look at this. But this is the thing that I kind of came up with, and finally I just update state of my component again with the weather info, so I have all of that available to me, right? So the component did mount is really imperative for this implementation. And then basically what I'm doing is just I'm rendering the output, probably similar to what Lucas has in his current implementation. I don't think I changed much here. There is some diagrams probably somewhere or not. I don't know.
There's some changes.
Yes, on daily temp, we do a line diagram. But he added some other diagrams later on. The interesting part is not this. The interesting part is actually this, right? Now, this is a component test, and I just want to talk you through this. I will actually code this with you at some point when we go into component testing in more details. But for now, so remember that you will be opening up this weather application later on in the bootcamp. But what I'm doing here is I'm unit testing this particular component. And components are like functions. They take some data and they return user interface, whereas regular functions, they take some data and return some data. That's the only difference between components and regular JavaScript functions. So what I'm doing here is quite interesting. In the beginning, I am importing all the necessary libraries that I need for my test to be performed, and I'm using a library called React testing library. It's called. So that's how you import this. And what you need are two modules. One that is called render, and the other one that is called screen. And the screen in this case is pretty much the subject. Like in RSpec and also in many other testing frameworks, you create this object, the main object that you are testing against. And in this case, that will be the screen, the rendered screen. I will come back to that in just a second. And then you have to import React from React, and the app component or the component that will be tested needs also to be imported in this test case. And if you're going to make some calls, you need Axios to be installed. So whatever dependencies you will be using in your test, they also need to be included here. And then in this case, I'm also included two mocked responses, very similar to what you do in Cypress, but they need to be imported separately here. And I have them stored in another folder that is called mocks, and then a file name, right? And then I set up two variables. One that is called Axios spy, and the other one is called get position spy. And what are spies? Well, spies are functions that function like observables. You take a look at a function and you basically observe it and check what is happening with it. And the Axios spy is being set up further down the line. We'll get to that in just a second. And the position spy is also defined in the before each block. But before we go into that, I just want to to focus on the jest mock that I'm doing here, the three consequent lines. What I'm doing is I am mocking out the entire React Chart.js library on this one. So we will not actually render that chart in our test, but rather by invoking a callback, I will say that the line, if my component is asking for a line chart, the only thing you return is a bit of HTML saying there will be a chart here. We are not interested in this chart, therefore we don't want to use it. And also the components tests, they need to be run in isolation. So any third-party components shouldn't be subject to your test. So you basically just replace the entire chart with this HTML. And still, it doesn't really matter. You just want to know that something is displayed there, but you're not going to look at it in the test. So you don't care what it says, but you have to return something, and therefore we are doing it like this. The interesting part are those spies in the before each block. So we have the Axios spy and the get position spy, right? Before I go into those, look what happens just beneath the get position spy. We are issuing a command that says render, and render, just to reiterate, is the module that we are importing from the testing library. And so we are rendering the app component, right? But before we render this component, we want to have those spies set up. The sequence here is important, right? So if we take a look at the Axios spy and the first line of this thing, only the first one, forget about the mock result value ones for now. The Axios spy is a jest function. Jest is the testing framework that we're using. And we are spying on Axios, right? The library that we just imported above, and the get action, the get function. We do not care about the rest of the Axios library. The only thing we care about is a get request that is being made, or the function get. And in the get position spy, what we are looking at is the app component and the get position function, right? So in the first spy, we're looking at Axios. In the second spy, we're looking at our component. Now, in order to be able to spy on it, we have to call prototype on this. So we're not looking at the instance of our app component, the one that has been rendered, but rather on the entire component itself. And that.
Right, so we're going to take a short little break here to run an ad so we can run the rest of this stream uninterrupted. So bear with me on this one, and we will be right back after these important messages. Or perhaps not. I don't know whether we are running an ad or not. It says on my in my dashboard that there are still things running, but I guess they are not. So we're just gonna resume the stream. I don't know how this interface works, to be honest. Anyway, let's get back to this thing. We're back. We are talking component tests. We're using jest and spies and mocks and responses. So bear with me on this one, people.
Therefore, we say app.prototype and the get position function. And we know that there is a get position function here because we already talked about it. So this is the one that is up here on the in the implementation. Now, knowing this, we can take a look what happens apart from us looking at it, because that is one thing, right? We look at it and we want to know what happens if it gets invoked or not. In jest, we can also mock the responses whenever this function is being called upon. Now, so let's start with the get position spy. That's the one that is interesting. Now, whenever this will be invoked in this test case, the value that it will return will be a simplification of the real value that is being returned by this get position function of the navigator geolocator. And we will return an object that has a property called coords, and that in itself is an object that holds longitude and latitude. And that doesn't really matter here what it is. It could be 60 or whatever values, it could be your real values or not. Now, every time this component is being run, there is, in that environment, there is no navigator. Nothing of this inside of this function will be executed, but the only thing that it will return is this object coords lat 60 long 60, right? All of this will be omitted, and that's the only way you can test functions that are tapping into the browser object, the window or or document object in isolation as a component test. Okay, so that is what the get position spy will return. We will look at it, see if it's being invoked, but also we are in control of what it returns. Now, in the Axios situation, it's pretty much it's a little more complex. We know that this Axios.get is actually used twice, right? If you look at this component did mount, on one of the lines we are hitting the open cage API using the Axios get, and then on the next consequent line we're hitting the open weather map also using Axios get, right? So the challenge here in our test is to be in control of those responses. So in Jest, we have this fantastic functionality that we can chain those responses. And that's exactly what I'm doing here. The first time Axios get will be called, we are going to respond with open cage response. And the second time it's being called, we will respond with open weather response. So that's a form of an interceptor that as we do in Jest, but on a lower level, right? And we can be in control or stay in control of what sort of response this will yield, which is pretty good.
A quick question. So what if, for example, we call the same thing twice? Should we just chain it like weather response and then again weather response, or is impossible to have a situation?
If you only call it once, like the same one, in this case we are calling it two different APIs, right? But let's say that we would never call the open cage, for instance, right? Then you will just use a function called saying mock resolved value, and not once, but it's actually called mock resolved value, and just pass that in, and that will always return the same thing, right? But I think that in Jest you have mock resolved value twice, perhaps. We can check that out. Jest mock resolved value. Let's see.
Is the return? Is that not there?
Value once. Right. Well, I would reset it probably, but no, you can't. Yeah, I would just do mock return value and then reset it if you want to change that response somehow.
Maybe it takes an option or something.
Yeah.
Of how many times.
Yeah. Could be. But it depends a little bit, Seva. Does that kind of answer your question?
Yes.
And again, never underestimate the power of documentation, because all of this stuff is actually documented, right? So you can see different examples and so on this one, right? So as you see here, for instance, right, you have a mock here. So you have mock result value default, and then you say once and once, right? So you can chain all of these stuff, right? Again, it depends a little bit on the use case. But let's continue. Once we have set up those spies, we are rendering the component, right? So now once we have executed this render function, we have screen as available to us, right? But what we want to test for, and look at the two it blocks that we're using here. Now, it calls get position, and then we say expect get position spy to have been called times 1, right? So we can count the amount of times the get position has been called, and if we look at the other one, it says call weather API, or call APIs probably should be it should be renamed. Naming is really important. But we can say that here we assert that the Axios spy has been called twice. If you look at it, which is the case, right? Because in our implementation call, we're actually using Axios twice. First for the open cage, and then for the open weather. But then So we have that out of the way. So we use that part of functionality of these spies to look and count how many times that they have been used or invoked, right? But then we also really use the response that these spies are returning to us, because now we can say that the screen should have, get by text, your location, VROOM, and I'm using exact false for some reason. Probably it was part of a bigger string, so I just wanted to soften the assertion, and just call to be in the document, right? So your location VROOM should be present in the document, and the temperature 22 Celsius should also be in document, right? And this, of course, depends on the fixture, and the fixture is defined in any of these two responses. So this is an example of how you can use spies in your test, and also have them return some values. And that is a powerful feature in Jest, which is the framework that we're using, because you can actually do it in that framework. There are other frameworks that do not have this possibilities. You've heard me talk about Sign-On before. Sign-On is another library for spies and mocks that we could in principle use. But since Jest is included in our React apps, scaffolded with the Create React App scaffolder, and it is actually more powerful than Sign-On, we should use this one, right? And yeah, now your challenge, if you want, like really extra challenge, is to actually write this implementation and this test. And if you are running into trouble, and you will run into trouble, I will be the standing guard and ready and prepared to help you out with this. Now, this kind of tests are extremely good to know about, and it's part of the acceptance unit test or cycle, or test-driven development cycle, when you work with front-end applications. But not many people are actually using this today. And if you do use it, it will set you apart from like 95% of the developers out there, and will strengthen your CV enormously. Right. That's what I had for you at the moment. Any questions?
Nope.
Nope.
No.
The question is basically probably, well, the way we did, we basically test the stuff in documentation, but with this intercept stuff, right? So why anyone should prefer, for example, spy over intercept, maybe, or it is like the same thing but just a different implementation?
Right. Okay, so that's a very good question, and it's a question that you might struggle with many times, and there is a blur, but so there's a gray zone or an area of overlapping tests, right? Now, Cypress is an end-to-end test framework, right? And what you do when you use your interceptors is basically to say to your browser, hey, do not make any calls. Just if anybody want to make a network call, just return this, right? And that's it. So that's a very, you're just like guarding your borders, like you're like a border agent, right? Stopping people from coming in and stopping people from coming out, right? As a Polish guy, I know a lot about that. Anyway, but that's basically like you're guarding your domain, and this is it. I want to be as isolated as possible from any outside interference, right? But in general, end-to-end tests are very straightforward in terms of you interact with your application and you just look at the end result, right? You click on a button and it should change the color of your message box, or you do something and you're looking for the end result on the user interface. That's what Cypress does, and that is what Cypress does best. Now, what if I would compare this to something? It's like when you sit in your car and you press the gas pedal, right? The car moves faster. When you hit the brake, the car stops. That is the end-to-end test. You do not test how that happens. Do you understand? You do not say that when I press the gas pedal, more fuel is being injected and burned, and more power, yada, 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 and all of that shit that happens with a combustion engine. So you don't really care about what happens, or how it happens, sorry. You care about what the end result is, okay? That's the end-to-end testing. You do not look underneath the hood. Fuck it. Now, in component testing, that is exactly what you're doing, right? If you think about the spies here, like, is it important for you to know whether the get position function has been invoked or not? Well, in acceptance tests, that is not the case, right? You don't care about that. But in component testing, that is actually the case, right? That is like, I am looking for more for how things are happening rather than the end result. But for the one that really paid attention, you could also see that I did have a test saying that, oh, your location is 0 and your temperature is 22. And that is the overlap, right? Because you are actually testing that already in your acceptance tests, but you could in principle test that in your component test as well, because you are making a call to an API, you're looking for some sort of response, and then checking the actual output, which is what is being done with that response, is not totally wrong, right? But you will end up in a situation where you are testing for the same behavior, both in acceptance tests and in component tests, right? And that is the problem. But the component, I would say that the component tests are mainly focused on the how thing. What function is being invoked? What does it do with the data, and how does it play it, and so on. And the things that I showed you now are very, well, they are not basic per se, because we do use spies and network calls, and that is pretty advanced, but we don't do much. We only had 4 it blocks here, right? Whether the spies have been called upon and so on, right? Now the spy functionality is pretty powerful. You can have asserters saying that it has been called with certain amount of data in, and so on. So there are many more powerful features you can use, but basically just to answer your question as short as possible, is you test the how things, like how is it happening, whereas in Cypress you are testing what the end result will be, and you do not care about the underlying stuff now. And again, if you think about it, it is easier to test acceptance, to write acceptance tests, because you don't really care about the underlying technology and how things are happening and so on. You just press the gas pedal and you drive fast, right? And you hit the brake and you stop. And this is the same thing with E2E tests. Whereas here in the component tests, you need to have a deeper understanding of how your components actually work and how they perform and what they do and so on. Does that answer your question?
Yeah, so it's like one tests the interface, another one kind of tests the code more, basically.
Yes, and when we say interface, the usability, right? That's what we call them acceptance tests, because like you sit down with a client and you say, yeah, if we do this, then the end result will be that. Is that okay with you? Yes, it is. Good, right? And then we move on, right? You get an acceptance for what you did, what you built is actually what the client really wanted. And you would never show component tests to a client. Like in a client session, you would never sit down and say, oh, and by the way, I am using this function or this library to display this. They don't give a fuck about that. They do care about the end result, right? When you sit down and brag to your fellow developers, then you should definitely show them component tests. But joking aside, component tests are really important out of a documentation perspective. You understand? Like, why, apart from playing a very vital role in development processes, where you actually write functionality in this test-driven way writing the component test is good for you because then you know what sort of implementation you write, but also as a regression test. Like, you want to make sure that they stand the ground over time when more and more functionality is being added, so that, you know, they actually continue to return the data that is needed for, you know, A, but also perhaps B, C, and D when complexity grows, right? So handing over a project to another developer with only acceptance tests is good. If you can have acceptance tests and component tests, it's even better, because that developer might sit down, take a look at the test suite, and so, oh, okay, so this is the data I pass in, this is what the end result will be, this is how shit is going down and happening. Okay, let's run the acceptance test, and we read through that, and that, you know, and we can understand how users are supposed to use our system, right? And that is documentation. Just to find, as a final word, when people say that Agile is anti-documentation, it is not, because tests play that function, that role in our flow. I will probably stop talking now. There's some food waiting for me, and you probably need to stretch your legs. Let's perhaps take 5, Lucas, and you will set up that session and talk them through the weather app that you built.
Do some show and telling.
Right.
Definitely.
That does it for me, folks. I see you around 2 o'clock. I will leave you in the capable hands of Lucas, and he will inspire you to great deeds moving forward. All right.
Right, and as a bonus, this would be the main part of that presentation. Let's see if we can get. Oh, there. Oh, that was humongous. Let's see. Let's make me a little smaller here. Don't have to be that big. So that was that, right? Now, in terms of let me make myself a little louder here. There we go. Right. Yes. So in terms of the actual implementation of the things that you just saw me do there, let's pull some things up on the screen here. So I'm gonna cd into projects and weather app. No. React Native. Right. So workshops. Open weather. Right. Open weather app. And I I wrote these tests that I was just showcasing for the guys on a separate branch that was called experiments. Why did I call it experiments? Not really sure, to be honest, but here they are. Let's pop this open in our editor like this, and we will get this thing. Well, perhaps I need to get rid of the .env tests file. Right, so let's go over here. Let's close these guys for now. So in this particular use case, we have some integration tests or acceptance tests, which are written in Cypress, and this is a very simple one. This is exactly what Seva was asking about, whether we should or should not test similar functionality in acceptance tests versus component tests. Now, here we are actually stubbing out some functionality in the browser. We're telling our browser in test environment that when you are visiting the application in your browser, this is the command for that in Cypress: visit and then a path. And since this is a single page application, we're just visiting the root path. Then we are invoking an onBeforeLoad function or callback, and we are stubbing the window navigator geolocation function, the get current position function, sorry, to return this stub location whenever it's being invoked. And since we are actually invoking that in our app component then the browser will think that it is in this case in Denmark. Why Denmark? Well, because that's what we settled for when we wrote this test. You can be in Paris, you can be wherever, and that is defined by this latitude and longitude, so that you select. Now, if we look at the app component again, as we did in the presentation, we are hitting. Let me make this a little bigger. We are hitting the this API using Axios and passing in this latitude and longitude that we got from this call to get position. Now the difference now between the implementation you saw earlier on is that I am extracting the keys into an end file, but that's pretty much the only thing. Now, if we want to look at the component test, that test is placed in the spec folder, and that is my choice. I come from a different world where we refer to tests as specs, and that is from the Ruby on Rails domain. The default folder that Jest comes predefined with is called actually tests, but I renamed this one to specs because I feel more comfortable with that name. And in that folder I have another subfolder called mocks, and this mocks folder contains two files, the OpenCage mocked response and OpenWeather mock response, and these two are pretty much the same as the ones that we're using in Cypress. In Cypress they are in JSON, but here they are JavaScript files. So here I'm actually exporting this this OpenCage response variable or object rather, but they are pretty much the same thing if you look at them like this. So they are used in two separate ways. And the same thing goes for the OpenWeather response, which is the same thing as we are using here, but this one is well, this one is in JSON, and I just copied this. This could in principle be a real object, so I don't have to have those double quotes. I could in principle use this if I want, but that's totally beside the point. If we look at the test itself, we are doing what we are doing that I already talked you through. We have the import of these mocked objects here, and we are pretty much just using them for these mocked responses from the Axios get response. And this is pretty neat. It actually took me a while to hammer this one out based on the documentation of Jest, to know that my spies could not only return one response, but I could chain these things and respond with a different mock on consequent calls, and that is pretty neat in my opinion. And again, this is not a very extensive test in any way. It's pretty straightforward. We just test for whether these has been called using in the entire process, in the life cycle of the component when the component is being rendered, if the get position is being called, and if the APIs are actually also invoked. To calls to API are made to both APIs are made. Let's see, I can do option right APIs. Now I can just escape this character. Right, so let's see if we can run this one. So I can run this in two different ways, because up until now it's all been theoretical. I've been talking a lot about how I build these tests, but it would be probably interesting for you to see how to run them. And in my package JSON, before I do that, in my package JSON, I have a command to run this, and we are just, well, we have one command for running Cypress tests, but we also have one command to run our jest test. So that would be yarn test, which is, I think, scaffolded directly for us when we use the create React app. So that should be pretty straightforward for you guys to follow. And jest comes pre-installed with that scaffold. That's also good. So let's see if we just clear this one up, make this a little bigger for you, and do yarn test. We should in principle go green, but you never know. The runner starts, and we are totally okay. Calls get position, calls to both APIs are made. I missed an S there. Has city name and has temperature. Right. So I would just probably I would just rephrase this to is expected to call get position, and here I will just say is expected to make calls to both APIs, and here I will say is expected to render city name, and here I would say is expected to render temperature. I think that would be a better way to do this, and we are running the tests in the background because of the way this is set up, and we can say we have a pretty neat setup here, and everything is going green. Now, as a bonus, there's always a bonus. I can show you how we actually can run these tests directly in VS Code, which is pretty good because then we can also debug this. I think I have this set up here, so let's have a look at the VS Code. There's a hidden file called VS Code, and there is a launch JSON. This needs to be set up manually, and this is called debug CRI test. I don't know why CRI test. Let's remove that. Launch node React scripts. That's what we are launching. We are passing in some arguments, and I think we should be able to run this. So we go to the runner in this debug with a player button on it, and you can choose some of your configurations. I only have one configuration in this particular project, and I can just run it by clicking the green button here, and a terminal opens up. It says that the debugger is attached, and it stopped. Yeah, there was a debugger here. I can continue the run. And we see the output of these things. It is not colored. I might have missed something in the configuration, but this is definitely running. We can just make sure that this debugger is gone from here, and we can run this again, and this should be pretty straightforward and just being executed for you. Right, there you go. Now, the good thing is that we can debug this much better, and we can put the debugger pretty much everywhere, and you can do that by setting a breakpoint in VS Code by clicking on the side of the we can click on the side of the line of code that where we want to set the breakpoint to just add this red little dot, and I just do it on line 30 for this one, so which means that I will have all of these lines of code that comes before the dot already executed. Let's see if we can get that. Now this will be hit at least 4 times. There we go. This is the first step. I can go to the debug console in my VS Code like this, and here I can now ask what is the position, so pause, and we can see those coordinates, and we can see that longitude is 60 and latitude is 60, which proves the point that this function that I was mocking out actually worked and returned this mocked value for me, right? If I should now step forward at least two steps, I could take a look at the location response, and the location response might be or might not be there yet. It depends a little bit because it's an await function. It is there, right? So we have the data like this, and we can see that there are all the things that we wanted to get from that API call are actually there. This is a pretty big object, but you can see that the formatted address is in Virum in Denmark. And you can see some components here. And you can see postal city, which is what we are using here, is Virum. I am not in Virum in Denmark at the moment. I'm actually in Gothenburg in Sweden, but I'm just proving a point that this stub actually worked. So that is the good part of running these tests in this way from inside of VS Code, because it helps you with debugging a lot. There is another way to debug these tests, but this is by far the simplest way to do that. So we can release this one, and now this will be hit 4 times because I have 4 hit blocks. Now I can remove this and I can move over to the test itself, and we can set a spy on, or not a spy, a breakpoint here in this particular block, and actually just add dot only to this one. That will make sure that only this particular test is being run. Let's do it. Now there we go. Now we have stopped in this particular place, which is a good thing for me. And now I can take a closer look at the get position spy. If that is interesting, we go over to the debug console, and we just go to get position. We just type in get position spy, and you can see, well, right, and we can see what this actually returns for us, right? So that's a neat little thing to do, to set up your VS Code to actually run tests directly from your IDE. Anyway, that kind of does it for us. Thank you very much for sticking out. If you are interested in various aspects of testing, whether it's component testing in your JavaScript framework like React or Vue, you can do this in Vue, of course. Or if you're interested in acceptance tests or end-to-end tests that checks other parts or checks your application from a different perspective, then feel free to hook me up. You can always reach me here on Twitch or through my website, Craft Academy. I'm also at agileVentures.org. And I'll see you in the next stream. Thank you very much for hanging out with us today. Take it easy. Cheers.